All right, so we are going to find the length of a diagonal line from point A to point B in this rectangular prism. What does it mean to be a rectangular prism? What does that sound like to you? So it's the shape of a rectangle, but what's the most important thing for it to be a prism? It's three-dimensional, absolutely. So we are going to figure out how we're going to find the length of the diagonal. Imagine you had a box from this corner here through the box to the front corner here. So we want to try to still use right triangles. Even though it's three-dimensional, we still have right triangles in this object. Now, we know a few things here. We know that the height of our box, and I'll just refer to it as a box, is 12. We know that the length here is 4, and that the width here is 3. So we're going to look for right angles that associate or are related to this diagonal. So take a look at how I drew that line. If I needed to cut out a slice, imagine I took a knife and I had a box. Probably easier if you could imagine Play-Doh because you could cut it. If I had Play-Doh and I actually cut a slice from the top right corner to the bottom left corner in the front, and I had this slice here, what shape do I make when I cut it off? I made a triangle. But could I use that to figure out this diagonal? Yeah. If I wanted to use the Pythagorean Theorem, what would I need? I would need a right angle. Do I have one? Yes. With that red, imagine this cut. Would this make a right angle? Yes. It would. Tough to visualize on the board, but again, imagine you had that shape. If I had that line going straight up, and then this other one flat on the ground, it would look like that if I turned it on its side. So I would need a right angle, which we do have. What else would I need in order to use the Pythagorean Theorem?
Know 2 sides.
I would need to know 2 of the sides. Do I know 2 of the sides?
No, but you can't find it out.
I don't know 2 yet. What side do I know? I know the height. Right now I know the height. Okay, so let's take out the height here of 12. Okay, and I need to figure out that diagonal E, but I somehow need to figure out that C value. Take a look here. How could you describe the position of this C value in our rectangular prism? Where is that? This line here. Where is that in the prism?
3.
Yeah, it's actually this diagonal between the 3 and the 4. What shape does this make?
A right triangle.
That also makes a right triangle. Could we use that to figure out C and ultimately figure out E?
Yeah.
Yeah, we could. And that's what we're going to do. So in the small triangle here, and again, we cut this. What is the length of C? You have a right triangle with 2 sides, so you can use the Pythagorean Theorem. What is the length of this leg? Say again? Yeah, this leg would be 5. How did Christian get 5? That is a Pythagorean triple. If I have a leg of 3 and a leg of 4, then the hypotenuse of that triangle would be 5. What would the calculation have been? Good. 3 times 3 is 9, plus 4 times 4, which is 16, which gave a total of 25, and just like Helena said, the square root of 25 is 5. So I now know that C has a value of 5. So how does finding this value help us to ultimately get that diagonals?
Gives you another leg.
It gives me another leg, absolutely. So now, could I find that diagonal of my rectangular prism?
Mm-hmm.
I could. Try to find it.
13.
So everyone should be trying on your calculator. I know some of you have already gotten it. But as everyone else is still trying to calculate, can you give me what you put into your calculator? 5 squared. Good.
12 times 12.
Plus plus 12 times 12, good, which is, okay.
You get 169.
What do you get?
169.
169, and then
You find the square root of 169.
square root of 169 is 13. So notice here, just because you were not given both legs of that original shape doesn't mean you can't use the Pythagorean theorem. And you will see this, because as you advance forward with the Pythagorean theorem, the idea is that you can find the right triangles, just like we worked on last week, where you had some weird shaped triangles, but you were drawing lines to create a right triangle. That's the same thing, gentlemen, please stop. That's the same thing here with a three-dimensional figure. And it's hard to see a cross-section on the board, I know that. But if you can envision cutting that box in a diagonal and trying to figure out what the length of that diagonal was, you could use the Pythagorean theorem in that way. Oh, we already found that. So when you know the dimensions of the prism, what could you do? What do you need to do in order to find that diagonal? When you see a three-dimensional figure, typically with the Pythagorean theorem, they're going to want you to find the diagonal. What must you have in order to find that diagonal? You need to have two of the legs. And if you are not given both of them, what do you think you're going to have to do? Find one. You're going to probably, more often than not, have to find one like we did here. We couldn't calculate the Pythagorean theorem here until we had this bottom leg. But being given these two dimensions, we now had the ability to calculate the Pythagorean theorem. And again, just a second step, another step to getting another leg of my rectangular prism's diagonal. I want you to try this one. So you can draw this, if you want to draw this prism in your notebook, you can. If you want to just utilize the dimensions, you can. You're going to find the length of the diagonal from this corner here, this front, bottom, left corner, to the top, back, right corner, this diagonal. What we know of this rectangular prism, we know the height of the prism is 8. We know that this front width here is 9, and we know the length of the entire prism is 12. Let's take about 4 minutes. You're going to have to figure out where you can create that right triangle. I'm going to add a little timer just to keep us on track. Oh, calculate.
No.
If you don't have a right triangle, remember what we just did. We created one. Is that the diagonal? Draw it down. Draw it. Thing is, if you draw it, you'll be able to create the right triangle in front of you. Three-dimensional on a two-dimensional surface are really challenging. Think about how you can best visualize. Where'd you get that? Why'd you add them? Do you already know the height of the prism though? Okay, so is that the diagonal? Does it look like it made a right triangle? Yeah. This, and that just made a right triangle together.
8 o'clock. Okay. 8 o'clock.
Alright, let's pause where we are and go back. But this is why, as we go through a lesson, you should write something down. Some of you don't have books open. It's challenging to refer back to something we did without something to go back to. So let's recap before you try an identical example. An identical example. In this rectangular prism, if we're trying to find this diagonal, we need a right triangle. I've drawn one for you in red. But think about what that right triangle is made up of. It is made up of the diagonal we are trying to find, which would be here. The height of the prism, which we are given, here, or here. And then this bottom leg that I do not know. So in order to find one of the legs, we know 12, and we do not know C. So I can't find E yet. I can't find this diagonal yet. I need to know the other leg of my triangle. Now we took out this cross section here, this little triangle, and I can hopefully move it. This triangle here, my shape is a little off, but still the triangle there is made up of a leg of 3. That's not what I want. A leg of 4, and then the hypotenuse I don't know. But I need that line. I need this C value. Once I find that, which we determined before is 5, I could then find my diagonal. So take a look here. Same example. I didn't draw the entire right triangle this time for you. If you have a rectangular prism, still the same shape. This one's a little bit shorter, a little bit longer, but still the same idea. To find this diagonal, I need to create a right triangle. That has not yet been created for you. You do not have all the dimensions that you need yet. You have to find both legs before you can do that. Mm-hmm. Say it again. Which one? You're going to need that length. You're going to need that height. Think about this. Let me add this for you. If I have this diagonal, the triangle that I need is there. So how can I get all the sides of that triangle? For the diagonal, what part of the triangle is it that I'm trying to find? That diagonal, does that represent a leg or the hypotenuse?
A leg and a height.
This one.
Hypotenuse.
Yeah, so of a triangle, I'm trying to find a hypotenuse. Good, so I need to know C. What sides do I know?
8.
I know 8. Do I know this one?
No.
No. How can I find this? How can I find that? How could I find that, this line? So I can see this triangle here, right? That's a right triangle. What is the value of this line? Let's say 15. How did Christian get 15 for that line? How did he get 15? 15.
9 squared.
Yep.
Which is 81.
Yep.
And then 12 squared.
Yep.
144.
Mhm.
And when you add that, that's 225.
Good.
And the square root of that.
Yep. So now we have this. Do we have enough now to find C?
Yes.
We do. We do. Now, some of you might have seen that 9 and 12. That is a Pythagorean triple as well. It's the Pythagorean triple of 3, 4, and 5, but each number was just multiplied by 3. So 3 became 9, 4 became 12, 5 would have become 15. If you calculate it, it's still the same thing. So now how do we find C, that diagonal?
8
The
squared.
same, yeah, you're going to do the same thing. 8 squared,
64.
which is 64,
15 squared.
plus 15 squared, which is 225.
Then you add those, there's 289. And then find the square root.
What's that?
17.
17?
Yes.
So C is 17. This is a very difficult thing to visualize. I know that. Seeing three-dimensional figures on a two-dimensional surface like a screen is very challenging. And even drawing a three-dimensional figure the way I have still makes it difficult to see. But the one thing that I hope you do see, and I want you to try and look, especially as we go, we're going to do a couple of questions like this in the workbook before transitioning to something different. If you see this diagonal, it is created by the front, bottom corner, and then the top back corner. So if I needed to make a triangle, the other two legs have to be from here and here, and they have to meet at a spot. It wouldn't make sense for them to meet here. That's not a two-dimensional shape. It does make sense for them to meet here because the leg would be created by that line, and the other leg is what you would draw. If you have a diagonal going through a prism, one of the legs will also go through the prism. If you're able to draw that picture, just draw that line, you'll be able, hopefully at that point, to see this triangle here and then do your calculation. But again, with the three-dimensional, especially being on paper, challenging to visualize it, but still try to find a way to draw that visual so you have the triangles. You can use the Pythagorean Theorem, which is a concept with right triangles that are two-dimensional. You can use that theorem to help you with a three-dimensional figure. And that's what we worked on just now. Questions? Okay, we're going to try a few.